1.2, the slope of a tangent. So the definition of tangent. So a tangent is a line that intersects a curve at a single point. Okay, this is the highlight here, single point. So a tangent most resembles the graph near the point where it intersects, showing how steep the curve is, and it's called at that point of tangency. So this is a curve, this blue curve is here, and there's a bunch of different tangents drawn, okay? So this tangent, again, it's a line, okay? The single point would be approximately here, I would say like right in the middle, right? And what happens is the amount of space between the head of the line and the curve is going to be the same on both sides, okay? Because this angle in here that it's like so microscopic will have to be the same. And it's showing, like, for example, if we're looking at this line here, we're looking at a negative slope, so it's going down to the right, right? And it's quite steep there, right? And we can actually figure out what that slope is using algebra. Okay, tangent 2, T2. Okay, again, it's approximately going through this point here, and the amount of space between the line and the curve is approximately the same on both sides. Okay, tangent 3. Oh, by the way, tangent 2, we can see that this is an increasing slope, right? So positive slope. It's increasing to the right. So in this area, the curve is increasing. Okay, tangent 3, not as steep as tangent 1, but still decreasing. And then I want to highlight this, and we'll get back to this. This is going to be a focal point in this course. If you take a look at tangent 4, see how it's horizontal? Okay, what that means, that means there's like a turnaround point. And we've seen that in like grade 10 with parabolas, right? So at the vertex of a parabola, at that turnaround point, there's going to be a horizontal tangent. Okay, we can say turnaround point, but we're going to get more into this. Okay, so let's recall the slope m, okay, that's what we use in grade 9, of a line joining 2 points. So let's call P1, point 1, right, x1 and y1, and then point 2, x2 and y2. Well, the slope is defined as the difference in the y over the difference in the x. Remember, this is called delta. This is a Greek letter, delta, okay? And this means the change in or the difference in. Okay, so the difference in y over the difference in x, or simply y2 minus y1 over x2 minus x1. Okay, so this is, again, from grade 9. So what we would do in grade 9 is we would have a line, and we would join 2 points, P1 and P2, with a little triangle, and then we would say, okay, well, like, we would do the rise over the run. How much did we rise? How much did we run, right? Delta y over delta x. So the slope of a tangent to a curve at point P is actually called the limiting slope of a secant PQ. Okay, so we're going to go over the difference between a tangent and a secant is a secant, and this is defined later on, intersects a curve at 2 points, right? Whereas a tangent intersects at 1 point. So what we're essentially doing is we're drawing a line and we're choosing 2 points, and they're getting infinitely closer together, but they make a secant because we're choosing 2 points, right? So it's the limiting slope of the secant PQ. Q is just another point on the line or on the curve. Okay, as the point Q slides along the curve toward P, and I'm going to show you in the next diagram. The slope of the tangent is said to be the limit of the slope of the secant as Q approaches P along the curve. So let's recall from functions. Okay, find the instantaneous rate of change of the curve of x squared. F at x equals x squared at a point 4, 16. Okay? When we are only given one point P, so we're only given the point P, so this is like F at 4, obviously, right? F at 4 equals 16. What we have to do is we must choose another point infinitely close to P in order to find the slope. So what we would do in functions is we would choose some h value. Usually we would say, okay, h equals 0.01. And we would use the points P, A, comma, F at A, right? And remember, this is the function notation basically for y. Okay, and then Q, we would take whatever A is, so in this case 4 plus h. So in other words, it would be like 4.01, right? Like very, very close to 4, but h units away, which is 0.01. And then we would find f at 4.01. So in other words, the y value. Okay, so let's go ahead for example 1 and actually do this question in a functions approach. So determine the slope of the tangent to the graph of the parabola f at x equals x squared at point 4, 16. So we're going to use 4, 16, and then we're going to sub in h equals 0.01. So what we want to do is we want to find what is f at 4.01. And that's just if we take x squared, 4.01 squared. And I get 16.0801. So we're going to use 4, 16, and we're going to use 4.01, 16.0801. Okay, so let's go ahead and do instantaneous rate of change. So what we're going to do is we're going to do f at 4.01, and we're going to subtract f at 4, and this is all going to be over h, which is, in other words, we can use 4.01 minus 4. Okay, so we're going to use 16.0801 minus, so we could actually technically go x1, y1, and this is x2, y2, if you think about it. Okay, so minus 16 over, like, well, we can write out 4.01 minus 4 again. So I get 0.0801 over 0.01. Okay, so when we divide these, we get 8.01. Okay, so the instantaneous rate of change at 4, so if you remember, just as like a quick sketch, okay, this would be the parabola y equals, I should use f at x. F at x equals x squared. So if this was 4 and then this is 16, if we were to draw a tangent here that goes through that point, that tangent would have a slope of 8.01. Right? Okay, going back up here to this diagram, okay? So back up to the slope of a tangent. What ends up happening is, like, for example, so P would be at some X value. Let's call this X1, okay? And then Q, the point Q, we have to choose a point Q that's H units away from P. So that's going to be some point X2, okay? What happens is, like, we could have this line being the secant, but if we choose H to be a little bit smaller, so maybe H is going to be this small now, then what's going to happen is our estimate for this tangent is going to be way better, okay? So maybe that's going to be our Q. Then we're like, okay, you know what? Let's make it even smaller. So maybe this is our h here. Okay? And then we get smaller and smaller. So if we get infinitely close to P, like let's say, for example, P is going to be our point, and then Q is going to be right here, right? So the horizontal distance between these, which is like H, we're just going to call it H, is so infinitely small that it's going to be a better approximation for the instantaneous rate of change. And that's what it means when we talk about the slope of the secant as Q approaches P along the curve. So Q gets closer and closer to P, and when it's infinitely small, that secant is representative of the IROC. Okay, so the slope of a tangent at an arbitrary point. So let P, A, F at A, which is just obviously an x and a y value, be a fixed point on the graph, y equals f at x. So some curve, okay, some function. And let Q, x, y equal Q at x, f at x. So again, another x and y. Represent any other point on the graph. If Q is a horizontal distance of h units, and that's what we were talking about before. So h units would be this far away, right? That horizontal distance from P, so P and Q, then x equals a plus h, and y equals f at a plus h. Okay, point Q then has these coordinates. Okay, Q at a plus h, and then f at a plus h. And we'll see that in the next example. So example 2, considering the graph y equals negative 1 over 8, x plus 1, x minus 7. Okay, so I included the graph for us. And that's just a parabola, right, with x-intercepts negative 1 and 7. Okay, determine the secant to the point P 5, 1.5. So if you actually think about 5, 1.5, this is going to be your P value. And we're going to determine the secant, again, the line that goes through the curve at 2 points, at using x equals 4. So x equals 4 is going to be here. Let's call this Q, but we don't know actually what the y coordinate is. So that's okay. Let's go. What is the function at the number 4? So we're going to have negative 1 over 8, 4 plus 1, 4 minus 7. Negative 1 over 8, 4 plus 1 is 5, 4 minus 7 is negative 3. Okay, so negative 1 times 5 times negative 3, I get 15 over 8. So our actual coordinate is 4, 15 over 8, which we can actually label right here. Okay, so let's find the secant, like the slope of the secant. I should put that in. So let's go average rate of change. That's fine. So what we're going to be doing is we're going to be finding the function at 5 minus the function at 4 over the 5 minus 4. So we're going to go 1.5 minus 15 over 8 over, let's just go 5 minus 4 is just 1. So that's super convenient. And what we'll end up getting is 3 over 8. Okay, so this is negative 3 over 8, which makes sense because if we were to draw a secant line through Q and P, this would be a negative slope, right? And the negative, like the slope would be negative 3 over 8. Okay. B, find the slope of the tangent at P 5, 1.5 using h equals 0.01. So the slope of the tangent. what we're going to do is we are going to use f at, and it's going to be 5 plus h, which is actually going to be f at 5 plus 0.01, right? Which is f at 5.01. If you need to see that written out. You don't have to write these out. You can just skip to f at 5.01. So using the equation, we have negative 1 over 8, bracket 5.01 plus 1, and then bracket 5.01 minus 7. And we get 6.01, and we get negative 1.99. Okay, so when we calculate this, we get 1.4949875. I always keep a bunch of decimals because I know that h is a very small number, so we're always going to be moving it 2 decimals anyway. So let's go ahead and do the instantaneous rate of change because that's what we're doing when we're finding the slope of the tangent. So we're going to use f at 5.05 minus f at 5, and then that's going to be over 5.01 minus 5. Okay, so we get 1.4949875 minus this 1.5 all over 0.01. And just to highlight this, that denominator is always going to be h. Okay, so we get 0.0050125 over 0.01, giving us 0.50125. And this numerator is negative, so then our answer is going to be negative. Okay, and taking a look at 5, 1.5, again, if we look back up on this graph and we take a look at 5, 1.5 and we drew a tangent line, again, it's a negative slope. So that makes sense. All right, the slope of a tangent as a limit. So the slope of a tangent to the graph y equals f at x at the point P, A, F at A is m, right? So we used to call this the slope back in grade 9, equals the limit as the difference in the x approaches 0, right? So that h value, right? Delta y over delta x, it's also equal to the limit as h approaches 0, right? What we just talked about. And f at a plus h minus f at a all over h. And that's what I highlighted in the last one. That denominator is always going to be that h value. Okay, if this limit exists. Okay, so here are the steps. Find the value of f at a. Then what we're going to do is find the value of f at a plus h, and then evaluate the limit as h approaches 0 of f at a plus h minus f at a all over h. Okay, so example 3, let's actually use this. Using the definition of the slope of a tangent, just here, determine the slope of a tangent to the curve y equals negative x squared plus 4x plus 1 at the point determined by x equals 3. Okay, so first I'm going to do just the legwork. I'm going to find f at 3, right? So find the value of f at a. So this is step 1. So I'm going to sub in negative 3 squared plus 4, 3 plus 1. And you're going to get negative 9 plus 12 plus 1, and you're going to get 4. So my point here is 3, 4. I'm then going to find the value of f at a plus h. So here's the thing. we no longer have an h value. So there's no h value anymore. We're actually using h. So in other words, f at 3 plus h. Okay, so minus 3 plus h squared plus 4, 3 plus h plus 1. So what we're going to do is we're going to expand this, and we're going to get an expression with h's in it. So this is going to be negative, and essentially 3 plus h squared, if we want to actually write it out, is 3 plus h times 3 plus h. Okay, we'll go ahead and expand this. 4 times 3 is 12. 4 times h is 4h. Bring down the plus 1. And now we're actually going to FOIL this. So 3 times 3 is 9. Keep that in brackets because that negative sign has to be applied after. 3 times h is 3h. h times 3 is 3h. h times h is h squared. And then plus 12 plus 4h plus 1. Okay, so distribute that negative in here. We get negative 9 minus 3h minus h squared, and then plus 12 plus 4h plus 1. And all we have to do now is collect like terms. So I'm going to start with the negative h squared, and then the h's. So negative 3h plus 4h is negative 2h. Negative 9 plus 1 is, and then plus 12. I get plus 4. All right, now that we're done step 2, let's go to step 3. So now we're going to evaluate the limit. So let's go step 3. The limit as h approaches 0. So we want to write this out. Of f at, I'm just going to write this, f at a plus h minus f at a all over h. So we want to write out the limit, and this is tedious, as h approaches 0. So let's sub in. F at a plus h is going to be negative h squared minus 2h plus 4. Then we're going to go minus f at a, which is 4, all over h. Okay, 4 minus 4 goes away. And we're going to write out limit as h approaches 0. You have to do this all the way down your page. I'll tell you when you can drop it. So taking a look at the numerator, we can factor out an h. If I factor out an h, I'm left with negative h. We can factor out a negative h, so it's nicer. Okay, we're left with h plus 2 all over h. Okay, these two h's cancel out. This is your goal. So if you want to put your goal for the h's to cancel out. Okay, there should no longer be an h in the denominator. Okay, so now we have h plus 2. So I'm just going to do every single step this time. So now we have h plus 2. What we do here is we sub in h equals 0. And at this point, and only at this point, we can now drop the limit as h approaches 0. Okay, so as soon as you plug this in, you no longer have to write the limit anymore. So 0 plus 2, which is 2. Oh, my bad. There's a negative there. There's a negative there because we factored it out as -2. Now B, here's an extension. Determine the equation of the tangent. So when we talk about an equation, well, we know a tangent is a line, so we're really looking at y equals mx plus b. Then what we'll do is we'll use graphing software to sketch the parabola and its tangent. Okay, so here are the actual steps. Let's just put them above, it'll cover. Okay, to finding the equation of a tangent line. So, step 1, plug in m, x, and y. So we have one coordinate, it's 3, 4. That's going to be our x and our y. And then we also have the m. The m value is this instantaneous rate of change, right? That's what the slope of the tangent is, -2. So y equals mx plus b. We have 4 equals -2, 3 plus b, which is 4 equals -6 plus b. Bring it over. 4 plus 6 equals b, and b equals 10. Okay, this is all grade 9 work. We solve for b, so plug in, solve, rewrite. So therefore, y equals -2x plus 10. This is our the equation to the tangent. Okay, so graphing software now. So -x squared plus 4x plus 1. So here's our parabola, and then, so it kind of goes through like -0.2 and 4.2, 2, 5. So vertex is 2, 5. So let's go ahead and draw this. So kind of like 2, that could be 2. 1, 2, 3, 4, 5. Let's call that the vertex. It's going to go approximately here. And then 2, 3, 4, 4.2 is approximately here. Okay, so this is our parabola, which is like y. And then our point is going to be at 3, 4. Right, so this is point P, and this is our tangent. Okay, if we did follow this up, it would go through 10. And taking a look back at this, if we put -2x plus 10, check this out. That is a beautiful tangent, and it only intersects at one point. Okay, so for rational functions, because we just did a polynomial, rational functions, we're going to find a common denominator. So example 4, determine the slope of the tangent to the rational function f at x equals 3x plus 6 over x, and then we're given the point 2, 6. So let's do those 3 steps again. Okay, now step number 1, we're going to find f at 2. So we're literally just subbing the 2 into the equation. So 3 times 2 is 6, 6 plus 6 is 12 over 2. Okay, we get the point 2, 6. Well, obviously it's right here. Okay, now step 2, f at 2 plus h. So again, we're literally just subbing in 2 plus h into where the x is. Okay, so we're going to go 3, and then instead of writing x, we're going to write 2 plus h plus 6 over 2. Let's distribute that in. So we get 6 plus 3h plus 6 over 2. So I get 12 plus 3h over 2. Oh, my mistake. This on the denominator is actually 2 plus h, because this was also x in the denominator. Okay, now step 3, we're going to sub it into the limit as h approaches 0 of f at x plus h minus f at x all over h. That might be A, but those are interchangeable. Okay, so let's write the limit as h approaches 0, and we're going to sub in f at x plus h, which is 12 plus 3h over 2 plus h. And then we're going to subtract f at x, which is 6, right? This number right here. And this is all over h. Okay. Start with the limit as h approaches 0. And what we're going to do is we're going to take this 2 plus h and we're going to multiply the negative 6 by 2 plus h over 2 plus h. So this entire thing is going to be the numerator. 12 plus 3h minus, and remember to bracket, so this is 12 plus 6h. And this is all over 2 plus h. Now, I'm going to give you a trick about this divided by h. I actually bring it over to the side and write divided by h beside this. Okay, so the limit as h approaches 0, I'm going to show you what to do with this in a second. We're going to go ahead and distribute this negative sign into that second bracket. Just remember that we're subtracting this entire function. Okay, so we have 12 plus 3h minus 12 minus 6h all over 2 plus h. But instead of dividing by h, we're going to multiply by 1 over h. And that's going to come in handy, this trick here. And then this is going to be a theme. See how we have 12 minus 12 and those cancel? We're going to see that a lot. So if you have a bunch of cancellations, you know that you're doing the question likely correctly. So 3h minus 6h, I get negative 3h over 2 plus h times 1 over h. So we can go ahead and cancel out the h in the numerator and the h in the denominator. If the h in the denominator, like this divided by h, does not cancel out, then you've done something wrong. So I'm writing out every step just for the lesson. So this is our equation. The limit as h approaches 0 of negative 3 over 2 plus h. At this point, we can sub in h equals 0. We can drop the limit, and we get negative 3 over 2.